Hi guys, my name is JJ Khoza. Up to so far, we've now recorded 6 lectures. Lecture number 6 was about fractional algebraic expressions. We have covered these fractional algebraic expressions, and part of the work that I was doing there, I had to go back and explain again the rules for multiplying or dividing the fractions, and also to add fractions. Now, I just want to give you one more example whereby we have a mixed case for the algebraic expressions that are fractional. A mixed case, something that involves everything at once. And again, you must remember guys, I always emphasize the importance of knowing the rules. Know the rules. If you know the rules, you understand the rules, nothing will defeat you here. That's the only key to success. So let me just do this one. We have we have 1 over x plus 1, this is a popular one, plus 2x over x squared minus 1 plus 1 over 1 minus x. Okay, now we need to factorize this one, the middle term. We need to factorize it so that it can look like the others. We have 1 over x plus 1 plus 2x over, we need to factorize this. On lecture number 5, I explained factorization of the difference of two squares, factorization of the trinomials, excuse me, and I also showed you the product laws, and I showed you the factorization laws, how the formulas, I mean the product formulas and the factorization formulas. So to me this looks like a difference of two squares. So I am going to do it on the side here. X minus 1, x plus 1. This is what we are looking for. X minus 1, x plus 1, plus 1 over 1 minus x. This one kind of looks odd, but in our previous lecture, on lecture number 6, we did speak about examples that involve a change of sign. We need to change the sign here. We need to work with this thing. Let me just show you what we are going to do. If you have 1 minus x, 1 is positive and x is negative. So you want to rearrange this thing. The rearrangement has got benefits because it's going to suit the condition that we want, a condition that will enable us to simplify this expression further. So we have negative x plus 1. Okay, now let us take out a common factor of a negative 1. Taking out a common factor means dividing, guys. Taking out a common factor means dividing. You divide, because a factor by definition is a number that divides another number without leaving any remainder. So whenever you talk about taking out a common factor, it means you are dividing. Now we take out this common factor of negative 1. I'm not going to write the 1. I've explained that in previous lectures. So negative 1 divided by negative x divided by negative 1, it becomes positive x. And then positive 1 divided by negative 1, it becomes negative 1. This is what we are having now. This is what we are going to take. Okay? We have 1 over x plus 1 plus 2x over x minus 1 x plus 1 plus 1 over, now I'm bringing this, negative x minus 1. Now it looks good. Remember, we spoke about the LCD, and LCD, can we go back to that slide? Oh, alright, it's no longer there, I deleted it. But an LCD that will enable us to divide all the denominators without leaving a remainder. Okay, so I'm deleting this. I just want to create a space. I'm doing these side calculations. I don't want my work to be clumsy. And I also encourage you guys to do like this, you know, and also to avoid errors. You must not do these things off by your head. Sometimes you can make these mistakes, and they can cost you quite a lot. Okay, so now we are taking, let me simplify this. Here we have a negative, so this negative times a positive, it gives us the properties of the negatives. A negative multiplied by a positive, it's a negative. Let me just correct it right away. So here we have negative. There you go. The only thing that we need to do is to find the LCD. I'm looking at my denominators. I see two different things. The first is x minus 1. The second is x plus 1. I'm going to make these my LCDs. What am I going to do with the LCDs? I'm going to divide. I'm going to keep the same base. I'm going to make sure, not the base, sorry. I'm going to make sure that I divide this expression. So I'm going to simplify here. Essentially, what I'm going to do, I'm going to multiply. I will multiply. So when we multiply, we are going to have, on the first term here, we take x minus 1 x plus 1. We divide by x plus 1. X plus 1. All right. So we are going to have 1 multiplying x minus 1 plus, here we are going to divide this by this. So we already have x plus 1. I'm going to put x minus 1. What do we have here? This happens, and the 2x comes back as it is. Remember, here when we divided on the first term, this first term, we had x minus 1 minus, we take this term x minus 1 into x plus 1, we divide by x minus 1. So x minus 1 will be divided by x minus 1, will be left with x plus 1. So x plus 1. We had x minus 1 that we got when we were dividing the first term, and when we divide the second term, we got x plus 1. I think this is clear. Now you just multiply through distributive property, and the answer becomes 2x minus 2 over x minus 1 plus x, into x plus 1. That's it. Here we can take out a common factor. 2 into 2x divided by 2 is x, and 2 divided by 2 is 1. And we have x minus plus 1 and x minus 1. I bring this one this side deliberately because this is what I want to do. So the final answer is x over, is 2 over x plus 1. This is the final answer. I wanted to show you this. A mixed case. You've got to be able to work exponents. We are doing exponential expressions. On the exponential expressions, you need to remember the laws of exponents. Without the laws of exponents, there is nothing that you can do. Okay? I think I'm going to need more space. I move to the third slide. Everybody remembers laws of exponents. I'm not going to explain them again. If you need the laws of exponents, you must look into my previous lectures. Now, we are talking about exponential algebraic expressions that are exponential. They've got exponents. I mean, when you talk about expressions with an exponent that is a variable. This is different. So a person may talk about this, and I may also talk about 2 to the power x. Let me make this neat. This is what I'm going to talk about. This. The exponent in this case is a variable. It's no longer a number. And this changes the whole ball game. Everything changes. Right. I clean the board again. We studied the laws of exponents, and we have now dealt with fractions, fractional algebraic expressions. Now we are dealing with something different. Algebraic expressions with exponents that are variables. So let me give you this. These are exponential. We're still going to do it with exponential equations when we come to another playlist. I'm going to create another playlist for equations only. That playlist will have linear equations, quadratic equations, exponential equations, and logarithmic equations. Okay. Now, exponential algebraic expressions. What is it that we are doing here? What are we doing? We're doing one thing to make sure that the bases are the same. Why do we have to get our bases the same? So that we can be able to work with exponents, with these exponential expressions. They have to be the same. And that comes from the laws of exponents, so that it becomes simple to simplify. Otherwise, there is nothing that we can do if we do not follow that route. I am going to present 2 different types here, whereby there is a multiplication and a division with variable exponents. The other case is addition and subtraction with variable exponents. Okay. So the first case is multiplication and division. But what are the rules here? Let me just write you the rules. I like the rules. The rules are simple. 1, make bases the same. the same. You know why? When you multiply similar bases, what do you do with the exponents? You add them. When you divide similar bases, what do you do with the exponents? You subtract them. That is what you need to do. And we are going to deal with the first case. Case number 1 involves multiplication. Multiplication and division. And therefore it makes sense that we have to work with the same basis. You have to try by all various means possible to make the basis the same. Otherwise, it's going to be difficult to work. Here is the first example. You can see we are multiplying the bases. But these bases are not the same, are not similar. Therefore, it will be the first assignment that we need to tackle. Otherwise, nothing is going to happen. I don't think this is going to be difficult. It won't be difficult at all. When I look at these bases, I see that it is possible to have all of them with the same base. And that same base, it looks like a 3. How do I know? Here we've got a 3. Here we've got 81. Here we've got 9. Here we've got 27. And all these numbers are divisible by 3. So I can just convert them. I think it will be easy. So, how do I convert 27 and give it a base 3? Well, we're going to have 3 to the power of 3. Three to the power of 3, all to the power of x plus 2. Immediately here, I see one of the laws of exponents, and the name is power to another power. And when we have a power to another, raised to another power, we multiply those exponents. That is the rule. You can't change that. And 9 can be expressed as 3 squared. I see the same thing again here. Power raised to another power. Well, 3 is fine. We need to express 81 in terms of 3 to the power 4, all to the power x plus 1. I think we got it now. So let us multiply the exponents. We're going to have 3x plus a 6 multiplied by 3 to the power 6x, over 3 to the power 3x times 3 to the power 4x plus 4. Now we know the rules. I'm not going to go back and explain the rules, guys. We must be serious. We've dealt with this. This is the reason why I gave you the fundamentals, so that I don't keep explaining the fundamentals. Right now, I expect and I assume that you have gotten to a level whereby you understand your fundamentals. In this case, I mean laws of exponents. So I'm just going to give you an answer here. You all know what you are going to do. The answer, we will end up with 3 to the power 2 equals to 9. I'm not going to explain what we did. Here, we're multiplying same basis. The law says is actually law number 1 of the exponents. It says you keep the base and you add the exponents. Similarly, below you do the same thing. Then you are going to end up with a numerator and a denominator. Both of them have a similar base. What are you going to do? You will take the exponent of the numerator and subtract the exponent of the denominator. Straightforward. I think that is understandable, and it is understood. Let us look at a case whereby, here the one that I just did was about multiplication and division. What if there is an addition and a subtraction? Well, and subtraction. Addition and subtraction. So I will demonstrate this. You find that you may have this expression. Let me just write it. Okay. Here we can see we've got 4 multiplied by 3, and here we've got 9 multiplied by 3. Below, we've got bases of 3. So we've got 4 bases of 3. I don't think we have got much of a problem. It's pretty much simple. What can we do with this information? We can just rearrange. 2 to the power 2 represents 4. And we have 3 to the power 2x, subtracting a 3 to the power 2 representing a 9. Oh, what's this now? And we have 3 to the power 2x minus 2. All over 3 to the power 2x minus 3 to the power 2x, subtract 1. What can we do with this information? We have now converted all the bases into prime factors. All bases into prime factors. What is a prime factor? A prime factor is any number that can be divided by two numbers only. And those numbers, it's itself, the very same number dividing with itself, and 1, a number 1. Okay. We have done that now. I'm going to take out a common factor here. The common factor is going to be 3 to the power x into Alright, let me simplify this first because we have, let me not jump into the simplification. Let's move with the flow. I want to do the unbundling here. X minus 3 squared 3 to the power 2x and 3 to the power negative 2. Over 3 to the power 2x subtract 3 to the power 2x 3 to the power negative 1. The laws of exponents, they will allow us to work with this, okay? But by definition, we're not allowed to have a negative exponent. When we're here, we are taking out, we're about to finish now, we are taking out a common factor. Let me make it red. This common factor is a 3 to the power 2x. Inside, I'll be left with 3 to the power 2x divided by 3 to the power 2x is 1. Subtract 3 to the power 2 and divide the 3 to the power 2x by another 3 to the power 2x. We're left with 1. So it means we're left with negative 3 to the negative 2 over, we'll do the same thing here. We take out this factor, we'll be left with 1, subtract 3 to the power -1. There you go. I proceed with my blue pen now. This and that goes. You have this to worry about. We know that an exponent of negative is not allowed. By law, it should be like this. And therefore, it means we are talking about 1/9. Since we are multiplying here, it means this term, this 9, is going to be multiplied by 1/9. You see? That is what is going to happen. Alright. And this one, you are going to subtract. It's going to be 1 subtract 1/3, a third. And then you are going to end up with an answer of 9/2. That's the answer. I'm not going to dwell into this, guys. These are exponents. You must go back to our previous lectures where we deal with exponents. You'll be able to deal with this. We also learned about fractions, properties of fractions. They will help you to resolve this. We are done with the expressions of algebras with variables that are exponents.